Right, sorry, my phone actually overheated, so the video cut out. So the points they're looking for in this question, and it's incredibly likely to come up, is they'll first ask for what the type of mixture is. You say it's a racemic mixture, and they may ask about why it's a racemic mixture that's formed. And so you need to say that firstly, the nucleophile is equally likely to attack from above or below. So the point you've got in there first is that it's a 50-50 chance. You could say, yeah, there's a 50-50 chance instead of saying equally likely. You've said that attack from above or below. So we've got this approach from above or the approach from below. And then finally, about the molecule being planar. So the plane of the CO bond. So it's important that this molecule is planar. If it wasn't planar, we wouldn't get this stereochemistry of the product that's formed. We wouldn't get this 50-50 ratio of two enantiomers. So those 3 points I've got in there. So equal likely attack, 50-50 chance of attack from above or below, the point that it's attacked from above or below, and that it's a planar molecule. Those are the 3 points that you need to include. So I'll just do another one as an example. So if we take, let's take butane. So for this one, we've got, we'll do it with sodium borohydride. So we've got our H minus. So when this attacks, it can attack from above or below, which is going to form our it's going to form the two enantiomers of this. So this is a chiral carbon. We've got 1, 2, 3, 4 different things bonded to it. And then when we add some aqueous acid, we're going to form the alcohol. I'm sorry if you can hear the noise in the background. There's a building site next door. Right. So this molecule though is chiral. We've got this carbon with 4 different things, and we need to show the two enantiomers that are formed. So I'm going to take my chiral carbon, and I'm just going to, in the tetrahedral shape, just draw on all of the groups, and it doesn't matter which order I do it. So I just bung them all on in whatever order, but in that tetrahedral shape. And then I'm just going to mirror image that. So done the tetrahedral shape, but mirror imaged, and then I map across the groups. So the hydrogen goes over there. We've got the CH3, I'll do that C2H5. We've got the OH at the top and the CH3 over there. Now to justify this, we're going to form a 50-50 ratio of the two, which we call a racemic mixture. And this was because it was equally likely that it would attack from above or below the plane of this molecule. So there's a 50-50 chance whether it would attack from here or coming in from there. So this leaves us with the final thing we need to cover is writing the overall equations for the reactions. So if we take propanone and we'll react that with NaBH4 followed by HCl, H2O, we form the alcohol. Now we need to be able to write the overall equation for that. So this molecule here, this is CH3COCH3. Put that in a bracket. Now we're going to be sort of with the oxidation, where we use brackets O to represent the oxidizing agent. We're going to use brackets H to represent the reducing agent. And then we just draw up we write the structural formula for this molecule. So CH3 CHOH CH3. So I probably shouldn't have put the dashes in there. Right, and then we need to balance the equation. So we've added 2 hydrogens onto this carbon here. So this hydrogen and this hydrogen have been introduced. So we need a second one in there. So those are not too bad at all. The other one would be then for making nitriles. So the equation for the hydroxynitriles, we need to be able to do the overall equation in the same way. So we'll take the same molecule. in the overall equation, we're going to use HCN. Now, we do not use HCN in the reaction. If you use HCN, you're not going to get a reaction occurring. What you're going to use is KCN, but then you're going to follow it up with a source of H plus ions afterwards, and the CN minus and the HCN. Like in terms of the overall reaction, it's as if we used this, but we didn't actually. So when these react with each other, it's going to form cyano group, the OH, and our other CH3. That's been drawn terribly. That's the CN. And so for this one, all we have to do is just write out the structural formula for each of the products. There's nothing fancy to it. So this is CH3. CN. I'm going to do that again, I messed that up. CH3C. We've got our CN group, OH group, CH, and then followed by the CH3 down here. Right, so those are our overall equations. There's no balancing we need to do from this. We're simply adding a hydrogen and a CN minus group to it, which we represent as HCN. It is a real molecule, whereas H on its own doesn't actually exist. So we have to put it in square brackets. For this, we don't need to put it in square brackets. So that covers everything we need to know for that reaction mechanism and the related overall equations. I know it's not easy stuff. Go and do maybe some extra reading on top of this, and make sure the questions I'm going to set you get completed to a good standard.